Alright, so I want to do number 30 and 2.1. So they tell me the position of a car in miles is given by the function s of t, which is 11t squared plus t plus 100, where t is time in hours. And its velocity is given by v of t is 22t plus 1. Cool. Then they ask me some questions. So first, they want me to use function notation to express the car's position after 2 hours. Where is it? So is 2 hours, is that a time thing or a position thing? It's a time thing. Which function do I want to plug that into?
S of t.
S, right? Because I'm asking a position question, not a velocity question. So S of 2 is the answer to part A. And then they ask where it is. How is that different than S of 2?
You solve for S of
Yeah,
t.
it's sort of not, right? I could evaluate S of 2.
Yeah.
So if I evaluate S of 2, what do I get here?
11 times 2 squared plus 2 plus 100.
44 plus 2 plus 100. Okay, so I got 146 miles. Cool. Okay. Now, what's B? B asks for use function notation to express the question, when is the car going 65 miles an hour? That's a velocity question. Good. Okay, so I'm going to be talking about the function v. And it's 67 miles per hour. Is that an input of v or an output of v?
Is it an output of v?
That's an output, right?
Yeah.
V is a velocity as a function of time.
Yeah, because you want to know what
67 is a velocity, not a time. Or 65, rather. So 65 is what?
equals.
Yeah, equals v of t. I'm not sure when that's happening. Okay, see that? So this is literally me asking the question, when is the output of the velocity function equal to 65? We could solve that.
Yeah, just set it equal to the 22t.
Yeah, you get something, right? So part C asks a weirder question. Part C asks, where is the car? And I'm actually going to write this one down because I want to be totally clear. So where is the car when it's going 67 miles per hour?
You would use 67 as the velocity, then plug that time into the position.
Good. You can see that? First, I need to turn 67 miles per hour into a when. And then I'm going to use the when to figure out the where. You guys cool with that? So, bubble diagram wise, I'm thinking this. I have some kind of place like time, right? I have a function s that takes time and turns into miles, right? And I have a function v that takes time and turns it into what? What's v do? It takes time and turns it into a velocity. So maybe if I was being totally precise here, at least matching categories. I have an hours, right? That turns through s into miles and turns through v into miles per hour. And this question is saying, okay, you're starting with a miles per hour, right? So that's like, okay, you're here, right? So that's going to be 67 miles per hour. Now, what do I need to do with that?
Get the hours in there.
Good. We need to pull that back this way, right?
So that's going to be 1.
That's going to give me a when. So what's your when that goes with 67? So that's me saying, okay, 67 is what?
S of t.
No, v of t.
V of t, right? It's a velocity.
Oh,
So v of t is 22t plus 1. That's 22t plus 1. Okay, so what's your t then? T is 3. How'd you get the Jim? Perfect. So notice this thing here, right? This guy? That's v inverse. Right? That's me pulling back along the function v. So I pull back here. I found out this is 3 hours. Then what?
Plug 3 is S of 3.
Good. Then I want to find out what S of t is, so I push 3 over here. You guys see that? Okay, so there. What's there?
That's the where, so that's gonna be the SMT.
Yeah, so that's going to be S done to the point 3, right? And there's some number associated to this? 202. It's 202. Cool. So my answer to part C is what?
202 miles.
Yeah, it's 202 miles from wherever.
Starting point.
Yeah, I'm not really totally clear. I didn't read it closely enough. So it's the position in miles of a car driving on a straight road. So it's 202 miles from start or something like that. To check whether it's from the start or not. Oh, it's not. It's not. To check whether it's from start or not, what should I think about? Where's this thing start? Good, it doesn't say. How could I figure out where it starts?
The velocity is 0.
Close.
That would make sense though.
That would make sense. What if I didn't, like what if it was moving when I started the stopwatch?
Yeah.
You guys see, like, start is when not position or velocity is 0, but when time is 0.
But the time
So when-
started at 3.
When time is 0, right, my position's 100. So I'm already 100 miles out from whatever they're calling 0 in position.
That's what
And my velocity is actually 1 at time 0. You guys see that? So this is like, oops, we started rolling out of the gas station and you hit the stopwatch.
100 miles past.
Yeah, and you're 100 miles from home already. You guys see that? So this is 202 miles from what? How are you going to describe the?
From
time
when
zero.
you started.
It's not from time 0, but it's from position 0, whatever the hell that means. You guys see that?